Okay, I want to show you a demo of the interference of light waves. Now, interference occurs when you have two sets of waves or multiple sets of waves that are overlapping each other, and you kind of add them together. And sometimes they add up to be greater, and sometimes they add up to be less. We call it constructive interference. When you add them together and they become bigger, the amplitude becomes bigger, and we call it destructive interference when they add up and become less. Now, what I'm going to use is this little guy right here. You probably can't see it very well, but I'm going to use that middle line right there. Has openings, little tiny openings that I'm going to shine the laser light through. Okay, and so here, of course, is what the laser looks like if I just shine it directly on the whiteboard up here. Okay, however, when I shine it through these guys, what happens is each little slot creates its own set of waves, and those waves will interfere with each other. And so what I get on the wall is this, a pattern of bright and dark areas. The bright areas, of course, are constructive interference. The waves add together and it becomes brighter. And the dark areas are destructive interference. Okay? This happens, by the way, because of diffraction. Those waves go through those openings and diffract or spread out as they come through that opening. And you may recall that the bigger the wavelength of the wave, the more diffraction occurs, the greater the diffraction is. So we have red waves right here, which have, as light waves go, these are long waves. Let me line it up again here. I'm having trouble lining it up. There we go. Oops. Lost it again. There we go. Keep losing it. There we go. So here's the red light. Now I also have like a blue-violet light. Now these waves are much shorter. And what do you observe about these bright dots? Of course, they're not as bright this time. This laser just isn't as bright as the red one. But what do you notice about these dots compared to the ones from the red laser? Obviously, the color is different. The brightness is a little bit different as well. But there's something else I want you to notice about the difference between these dots and the ones from the violet light, the purple light here.